So today we will discuss about chemical equilibrium. What is chemical equilibrium? Chemical equilibrium is a equilibrium where the rate of forward reaction and the rate of the backward reaction is equal. If we consider this reaction, calcium carbonate solid is equilibrium with calcium oxide solid plus carbon dioxide gas, then in this reaction the rate of forward reaction means the calcium carbonate dissociates and produces calcium oxide and carbon dioxide, and the rate of backward reaction means calcium oxide and carbon dioxide combining with each other and producing calcium carbonate. So this is Rf, and this the rate of backward reaction. If we called as Rb, then Rf equals to Rb. Now that what is the evidence of a chemical equilibrium that the reaction is happening? Because if we see that the reaction is in chemical equilibrium, you can't realize, because you see that there is nothing happening, nothing goes to happening in this reaction. So if we consider this reaction, this is iodine, hydrogen plus iodine reacts with each other and producing hydrogen iodide. In this reaction, if we at 448 degrees centigrade, if we replacing this iodine by radioactive iodine, then we find the radioactive iodine in the HI. So it is the evidence that chemical equilibrium is happening and the reaction is also continue. It is not that in the chemical equilibrium the reaction stops. Next, chemical equilibrium is two types. One is homogeneous and another is heterogeneous. In the homogeneous chemical equilibrium, all the molecules are in the same state. That is, we consider the above reaction, then all the reactants or all the products or all the molecules are in the same state. So this is known as homogeneous equilibrium. And if we see in the first reaction, calcium carbonate equilibrium with calcium oxide plus carbon dioxide, in this reaction all the molecules are not in the same state or same phase, and so this reaction or this equilibrium condition is known as heterogeneous equilibrium. And if we consider a reaction A plus B, so in this reaction, if we consider the rate constant, not the rate constant of the forward reaction is K1 and the rate constant of the backward reaction is K2, then R forward will be Q1 the concentration of A into concentration of B, and R backward will be K2 into concentration of C into concentration of D. And this is you know how this is I write, because this is by applying the law of mass action. And what is the law of mass action? Law of mass action is nothing but the rate of a reaction is the stoichiometric multiplication of the reactants. Okay, now at equilibrium we know that R forward equal to R backward, So if we equal these two, then see what is happened. Now here Kc is a rate constant at equilibrium condition, and that this Kc equals to K1 divided by K2. So K1 is rate constant of forward reaction, and K2 is rate constant at backward reaction. So in the chemical equilibrium there are some rate constant such as Kp, Kc, Kx, Ka, etc.